explaining how we can incorporate the difference in frequency, a concept that is missing in mathematics, to calculate the mean and standard deviation. We'll be incorporating the difference in frequency to calculate the mean and the standard deviation. Let us look at this table. We fill up the table, then finally I'll be showing you the new formulas that I developed based on the difference in frequency. So X column, that is where we'll be putting the mid value of the interval we have. So the mid value of 0 and 10 is 5, while the mid value of 10 and 20 is 15. So we'll have a difference of 10. The data will be different by 10. So next there will be 25, there will be 35, there will be 45, there will be 55. Next, we just present the frequency that we have here, which is 2, 6, we have 9, 7, 4, and a 2. And the summation of this is 30. Next, we'll be filling up the column of the X, the F, this and that. Now, if you look at these 4 columns, this is what is making this method to be different from all other methods that exist in the mathematics, literature for calculating mean, standard deviation. So the X represents the half of the difference in data, and the F represents the half of the difference in frequency. Let us see how we can fill up this column. So how do we come up with the figures here? We subtract the last minus the first, then we divide by 2. So 55 minus 5, 50, divide by 2, 25. Then you share that equally among those terms that you have subtracted. The next one will be 45 minus 15, that gives us a 30. Then 30 divided by 2, that is a 15 here, and again a 15 there. Then we have 35 and 25. We subtract them, the result is 10. Divided by 2, we have a 5 and a 5. We are done. We go to the difference in frequency. We'll be subtracting in the same manner we are subtracting the data. 2 minus 2, 0 divided by 2, it's 0. We share them equally. Then we have 4 minus 6, that is negative 2 divided by 2, negative 1, negative 1. Then 7 minus 9, negative 2 divided by 2, negative 1, negative 1. Dx df is the product of what we have here. 25 times that, 0. Here we have negative 15, 5 times negative 1, negative 5, 5 times negative 1, negative 5, 15 times negative 1, negative 15, 25 times 0, 0. The summation of this, negative 15 plus this, gives me negative 20 plus negative 15 plus negative 5, that gives me negative 25 plus negative 15, that is negative 40. Now, just before we fill up the last column, when you observe the third, fourth, and fifth column, it looks like the data we have obtained has a reflection. If I place my ruler here, you realize that on top and bottom, in the third, fourth, and fifth columns, it reflects, there is a reflection of the information. We have 5 here, 5 here, 15 there, 15 there, 25, 25. Here we have a negative 1, negative 1, negative 1, negative 1, 0, 0. We have a negative 5, negative 5, negative 15, negative 15, 0, and 0. That in fact makes even this table more simpler than other types of statistics tables that we create. Last one is the product of frequency times the square of the x. So 2 times 25 square, that gives us 450. Then next one, we are multiplying 6 times 15 square, that gives us 1350. Then we have to multiply 9 times 5 squared. That gives us 225. And the next one is 7 times 5 squared. That gives us 175. The next one is 4 times 15 squared. That gives us 900. And finally, we are multiplying 2 times 25 squared. That gives us 450. When all these are added, the result is 5150. And the formula for calculating the mean, that is a formula I came up with. It is A plus the summation of the product of dx and df divided by the summation of frequency. Now A is the mid value. It is the mid value of the information in the x column. And how do we find that? You simply add 5 plus the last one, 55, you get a 60, then that is 60 divided by 2. Or you can add 15 plus 45, you still get the same result, or 25 plus 15, you still get the same result. So let's add 5 plus 55, then we divide by 2 to find our f plus summation of dx, df, we have negative 40 here. Then we are dividing by the summation of frequency. This gives us 60 divided by 2. Then we have positive negative, and the result here is negative 1.333, which is 30 minus 1.333 gives us 28.667. This is the mean. Using the new formula, our mean is this. Then we go to part B, where we are requested to find the standard deviation. So the formula that I came up with for standard deviation is this one here. Summation of fg x squared, we divide by summation of frequency minus this part, which I also call the statistical factor. Why is it a statistical factor? Because it is used to find many other types of problems. Also even used to analyze the data, and I'm still looking at how far we can go in terms of analyzing data using this statistical factor. So we are going to square it. Other problems, they use mean. I'm not using mean to find the standard deviation. I am using just this part, which is the statistical factor. So this is already here. We have 5150. So we have 5150 divided by summation of frequency x minus. The other one is negative 40 divided by 30, then squared. So this gives us 51 divided by 5150 divided by 30, 171.667 minus this divided by that, we have that as 1.333 squared. Then if we do the subtraction there, minus 1.333 with a square, we have 169.8898, and the square root of this one is 113.03. So this is our standard deviation, which can also be checked using the other odd methods. The answer will still be the same. Thank you very much for watching this video. More videos to come.